Okay, here we go with the beginning of chapter 4 for geometry. It says notice 22, apply triangle sum properties. And I just saw I did not write essential questions, so we won't do that today. Here are a bunch of definitions that you already quoted during the activity, so that's good, so you know all these properties. But make sure you know this little note here that I put. When the sides of a polygon are extended, other angles are formed. So when you extend it out past the polygon, so it's like here if I draw a pentagon, and if I extend each one of the lines out, kind of makes a fan. Okay, in that aspect, because it's like fanning around, you have interior angles inside the outside. Notice I'm always on the same side. It's rotating around, kind of like a windmill. These guys are all called the exterior angles of your polygon. On this theorem here that has 4.1, let me stop it and find out what number we're actually on. Okay, right here it has theorem 19, is our 19th one that we've had. It's in just chapter 4 in the first one. It says the sum of the measure of the interior angles of triangles is 180 degrees. This is something you should have learned in elementary, but if not, the activity 13 part 1 demonstrates that whatever triangle you create, those three angles add together to equal 180 degrees. On theorem 20, the exterior angles theorem, this was activity 13 part 2. It is telling you that the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent angles. These guys are called remote interior. A little picture of this, if I can draw it kind of small, you'll have a triangle drawn, and that kind of looks like a right triangle, but it doesn't necessarily have to be that. This guy out here is your exterior angle that they're talking about. And the remote interior are the ones that are not adjacent to it. So not this one right here on the other side of the line, but the two other angles. These guys are called the remote interior. Or in other words, saying the two non-adjacent interior angles. These two angles added together will equal the sum of that exterior angle. So if this is 3 and that is 4, together they are 7. That means this outside will equal 7. Alright, the corollary to this triangle sum theorem is saying that, okay, if we have the acute angles of a right triangle, they're saying that those angles will always be complementary. So I have a right triangle given to me. So that means I have a box in the corner. And it's saying that the acute angles, the top angle and this angle here, if I add those two things together, they will be actually complementary, which means they add to 90 degrees. And I hope that makes sense, because all the angles must add to 180. If one of the angles is already 90 degrees, then the other two must add to 90 as well. Alright, in the first example, it wants us to classify the triangle by its sides and by its angles. So if I look at the first one on the left, if I go by the sides, there is a 19, a 23, and a 9. None of them are the same, so we're going to say it is scalene. And then if I look at the angles, notice none of the angles are the same as well, but I do see up here at the top that I have an angle that's 110 degrees, which means it is obtuse. So we're going to call this triangle a scalene obtuse, and I'm going to use the triangle as abbreviation for triangle. If I look at the second example here, notice the sides, two of the sides are 4, where the hypotenuse is 4 square roots of 2. If I can zoom in a little bit. So I know two sides are equal, which means it is isosceles. And then notice it has a right angle in the corner, which means it is a right triangle. So together this is an isosceles right triangle. So to classify a triangle, you must classify it by its sides and its angles. On the second example, we have a little picture given to us. It says we want to find the measure of the angle BAC, so up here, as well as BCA. So we want to find the other two angles. Notice this is a right triangle, so I can use the corollary here that says the acute angles of a right triangle are complementary. I know this corner is 90 degrees. So that means the other two angles should add together to equal 90 degrees. They're complementary. If I combine like terms, that gives me 7x plus 6 equals 90. I'm going to subtract 6 and have 7x is equal to, looks like 84. And when I divide by 7, it tells me x is equal to 12. Now I need to plug it back in. So I have 3 times 12 plus 11 will be the one angle. That is, what angle is that? Looks like angle BAC. 3 times 12 plus 11 comes out to equal 47 degrees. And then I can plug it into the other side. And this will be the measure of angle BCA. And that gives me 43 degrees. And there's my two angles for this particular problem. Alright, on the part B, here is an example of an exterior angle. The exterior angle is here, and this angle and this angle are remote interiors. And my theorem 20 tells me that the exterior angle is going to equal the sum of the remote interior angles. So that means this outside angle equals the other two added together. So this will be 2x plus 76. If I solve this, I'm going to subtract 2. Gives you 3x minus 2 is equal to 76. And I ran out of room because I didn't start at the top. I'm going to add 2 to the 76. That will give me 3x equals 78. And then I need to divide by 3. Tells me x is equal to 26. So now I need to plug it back in. They want to find BCD, which is the exterior angle. So I'm going to do 5 times 26 minus 2. That will equal the measure of angle BCD. That comes out to equal 128 degrees. And then they want me to find the measure of ABC, which is this top angle. So I'm going to do 2 times 26. And that tells me the measure of angle ABC is 52 degrees. There's my other answer. Okay, here are your independent practice problems. I want you to try to work these out, and these are also the problems I'll go over in class. You do not have a summary to actually answer, but I do need to give you your password, and that is pencil. Once again, your password is pencil.